Now you can perform basically the same operation in the Grasshopper and Rhino environment too. And in Grasshopper, what we'll do is we'll define a range of points, first constructing the domain of the kind of start and stop for the x values, and create a range, and then with that range, we'll evaluate a function to compute the z values. Finally, we'll go through and construct some points, okay, using the x, y, and z values. Then after we've created those points, we'll go through and construct some curves, either a NURBS curve or an interpolated curve or a polyline. So a lot of different variations for the types of curves we can create within the Grasshopper environment. So let's take a look at how that same basic operation would work within Grasshopper. So it's all going to start with this whole notion of creating a range. And for that range, we start by creating a domain. A domain is just the starting and stopping point for the x values. So we're going to go from -20 to 20. We're going to create a domain of those. Okay. Then we're going to create a range. That range is going to, within that domain, break it into a number of different steps. So this is the number of different points subdividing it. That's very similar to what we do with a code block. Okay. Once we've gone through and created those range of values, we're going to use an evaluate function. I'm going to do something very simple. We're just going to multiply x by x. So we're going to evaluate the function x by x using these x values as the inputs. And you're going to see that's going to give us a little list over here of the x by x's. Okay, now you might want to see the result of all this. Let's go through and, oh, what did I actually do with the window? What I'd like to do is, let me just maximize this window so you can sort of see it over here. You can sort of see that big old function right here. Let's come on over and now look at creating some curves. After I've gone through and created the x values and the z values, what I'm going to do is aggregate them together using the construct a point. Okay, so this basically has a series of different points with x's and z's. And then I can put these together into a series of different lines. Let me kind of just break that apart a little bit. Let me, pardon me, disconnect this one. And disconnect this one so we can sort of see what they look like independently. Now, this is what the NURBS curve looks like, the smooth curve that's using those points as control points. Okay, zoom on in there a little bit. You'll see, though, that although it's a smooth curve, it's actually using them as control points, so it's not actually going through the actual points. Okay, so if I prefer, I could go through and use an interpolated curve. Now, that goes through all the points, but notice that when we get to the very tight point, okay, it's not doing such a great job of approximating things there. That doesn't look so smooth at that point because it actually has to go through the points, literally. Okay, so you have to watch out for the difference between interpolated curves and NURBS curves. At a large scale, they're very, very similar, but when you get to very small spacings, they actually can look very different. Let me disconnect that. And finally, let's just go through and show you what a p-line or polyline looks like. So that just creates them into, again, series of straight line segments. But again, at a large scale, that looks very similar to the curve. So one thing you want to think about is just really what kind of complexity you need for the curve. If a polyline which approximates the curve behavior or a true curve is necessary, because it's a little more work to go through and maintain a true curve. Often we'll go through and simplify things by just kind of creating a series of straight segments which approximate the curve. Okay. So that's the basic equivalent geometry in the Grasshopper environment.